Okay, these questions, they are related to vectors, and if you remember my very first class in which we just talked about what you are going to deal about in this course, like what kind of stuff you are expected to see in this course. I told you that they come in two categories. One category are the quantities which you call scalars, and the other ones are vectors. They only differ that one of them has direction associated with them and the others don't. So everything, I gave you the example of temperature that day, that if you talk about temperature in this room, you say that the temperature of this room is 25 degrees centigrade or Fahrenheit, whatever system you want to use, right? You do not say that the temperature in this room is 25 degrees centigrade in the direction of bell tower. That statement simply does not make sense. Okay, so in order to describe the temperature of this room, we only need a number like 25 and then certain units which you say degrees centigrade or Fahrenheit, whatever you prefer. But if I'm walking in this direction, then in order to specify like in which direction I'm going, I have to tell you two pieces of information. And the first one is like how fast or how slow I am going. That's my speed. And additionally, I have to talk about that I'm going in the direction of this exit door, or I'm going in the direction of bell tower. So these are two different types of quantities. The example of the first one is the temperature, that you just need a number 25 degrees centigrade. Or the second type of quantities are called vectors, and in this case it's the velocity. Like I'm going at a speed of 5 meters per second in the direction of bell tower. 5 meters per second tells me how fast or how slow I am going, and that direction in the direction of bell tower tells me where I am headed. So these are two different kind of quantities, and these are the only type of quantities that you will be seeing in this course, which means everything that you are going to study for the next 10 weeks or 7 weeks, whatever are left, you are going to, everything that you deal with, they are gonna be either a scalar quantity which only needs a number for their descriptions like temperature, or it is going to be a vector quantity like velocity, that I said that I'm going in this direction at a speed of 5 meters per second. At a speed of 5 meters per second means that I'm traveling a distance of 5 meters every second. That's what it means. So you are just going to deal with these two kind of quantities, not only in this course, in all of physics. You just deal with these two kind of quantities, which means that everything that you see around you, you can categorize them in one of these two kinds. Either that quantity can be scalar, or either that quantity can be vector. You take any example from around you, from your life, and they're gonna fall in one of these two categories, either a vector or a scalar. So we need to study the properties of such kind of quantities. Scalars are easy. They are just numbers, like all the numbers that you probably have seen in your early education in mathematics, they are all scalars. But the vectors are like special kind of quantities that in addition to some numeric value, you also need direction in order to describe them. And so this problem set, it is related to the properties of these vector quantities, like how we can add them, how we can subtract them, how we can multiply them. Probably you're not going to see the multiplication, but addition and subtraction, we have to follow special rules for them. And this is what these problems are about. So, ma'am, you can have this. So, for example, the first question, it's about addition and subtraction of vectors. So these vectors that you will be seeing in your book or in these problem sets, they are denoted by symbols A, B, C, D. That is just a name. Okay, you don't need to stick with using A, B, C, or D. You can use any alphabet you like. My name is Fussy. I can use F. You can use an alphabet of your choice. What is important is that when these vectors are representing a certain physical quantity, all the quantities that you deal with in your life, like when I'm walking, I have a certain velocity. Okay, so I can, in your books, the velocity will be represented by a symbol V. I can use a symbol F for velocity. That doesn't matter, but you should know that when you use the symbol f, you should know precisely which quantity you are talking about. So generally books use v because velocity, it starts with v, and so it's easier to remember that which quantity you are talking about. You do not mix up with quantities when you have a lot of things to deal with. So the general rules for adding or subtracting two vectors, the method is called head to tail rule. And it's as simple as the name sounds. It's a head to tail. You have to add vectors such that if you have more than one vectors, and let's take this example. For example, we have this vector, and let me call this vector f. I'm not going to use a or b just to make you get used to using any symbol. Just do not get confused. If someone uses a, you are not restricted to use a. You can use whatever you want. Okay, so this is a vector f, and let's say we have another vector in this direction, and I'm going to call this vector p. There are two things to note. I'm using a line on top of these symbols f and p. In your book probably, and in these problem sets probably they are going to use arrows, so it's your choice. Different books use different symbols for vectors, but either you put a line on top of this alphabet or you put an arrow that represents a vector quantity. If you do not do that, if you just use p, f, they are going to be considered as scalars. So you need to be very careful when you write these symbols, because this is the only way in which you are writing in your notebook or in your exams that which quantity you are talking about. So the way you write them, this is a vector quantity, this is a scalar quantity, so be careful about them. So now if these are two vector quantities, so you can add a vector quantity to another vector quantity. You cannot add two different kind of quantities. It's like if someone asks you what is the result of 2 bananas and 2 apples, you cannot say 4 apples or 4 bananas. That doesn't make sense, because you have 2 bananas and 2 apples. Those are two different fruits. You cannot just add them. The end result will still be 2 apples and 2 bananas. Similarly, you cannot add vectors to scalar quantities. In order to add vector, you have to have another vector quantity, and that's why I have shown here two vector quantities. So you can add them. The head to tail rule says, like, let's say this is your first vector, this is your second vector. Then the head to tail rule says you place the tail of second vector at the tip of the first vector. So this is the tip of first vector, this is the tail of second vector, and I'm going to place this tail at the head of first vector such that I do not change the direction of this vector. It's like I can move this vector parallel like here, and I can put it here. So my vector p will still be pointing in this direction in which it was originally pointing. Okay, and now I can connect the tail of first vector to the head of last vector, and this vector will give me the result of summation of vector f and p. So this vector, whatever color it is, let me call this vector r for resultant, and this vector shows the addition of vector f and vector p. Okay, so how do you write it? You simply write it vector f plus vector p. So this is the resultant of vector f and p. This is not like numbers. Let me give you an example why it's not like numbers. Let's say in case of numbers, let's say f was 4 and p was 5. In that case, r would be 4 plus 5, right? You can simply say that in case of numbers it's 9, but in the case of vectors it's not equal to 9. It will be equal to something else, something different from 9, and we are going to figure that out how we do that, but it is not gonna be 9, and that's why it is different from numbers which are simply scalars, that you cannot add them in the trivial way in which you used to add them, like 4 plus 3 or 7 or 5 plus 4 or 9. Vectors do not give those kind of results. That's it. That's all you need. Now generally what we do, we draw a coordinate system. We say that these two lines drawn perpendicular to each other. What it means by perpendicular to each other, it means that the point where they cross, they make an angle of 90 degree with each other. Okay, so these are two perpendicular lines. The horizontal line is called x-axis, the vertical line is called y-axis, and this system of lines, it's called Cartesian coordinate system or XY coordinate system. Okay, now the convention is that we draw vectors in this coordinate system. Why we do that? We see that these vectors have a specific direction and they have a specific length of this arrow. Okay, and it starts at some point and we need to know exactly where it starts, and that's why we try to plot them in this coordinate system such that we place the tail of vector at the point where these two lines cross each other, and we define this point like length at this point or distance at this point is 0, which means that this blue vector, let's call this vector A, it starts at 0 and ends at this point, whatever, how far this point is from this 0, which is called origin in this case. And now in this case you can simply add any other vector, vector B. Let's say we add a vector B to it, and let's say vector B goes in this direction. So this is your vector B. So in this case the resultant is gonna be this one. I'm going to call it R prime. Why did I use R prime? Because I have already used the symbol R here, so I just want to make it different from that one. You can use any symbol you want. I just picked R prime because I have used R. So you see these two diagrams, they are same. Okay, but this one is better. Why it's better? That you have put it on a firm grounds that now wherever the vectors are starting at this point, it's the point of origin. It's the point like where you start walking or where you, whatever you do. Okay, this is like the point, like this is where I'm standing. So if I start walking from this point, after 5 seconds you can talk with respect to this point how far I am or how far I have traveled. Let's say I have traveled 10 meters, which means that I have traveled 10 meters from this point. And you see then you have freedom in this. For example, if you stand up from your place and you start walking 10 meters, okay, your distance 10 meters from the point where you started walking, and so you can, let's say, draw a different coordinate system, again similar to lines, and you say, okay, I started walking from this point. Okay, it doesn't really make any difference, so it's your choice. But you have to have a coordinate system like this from where at which point you mark your origin, like the starting point. And after this, you see this first question, it just becomes very easy. I'm not sure if you have this with you or not, but in this case, this first question, it shows that, okay, I'm going out. It shows that vector A is in this direction. So this is your vector A, and vector B is in this direction. This is vector B. And at this point, the first thing that you need to do is to mark your coordinate system. So what you do, wherever these two vectors tail are meeting, you can start your coordinate system from this point. So this is now my coordinate system, x-axis and y-axis. It's going to help us in the questions that are coming up in this problem set. But now you can use that same rule of vector addition. You move the vector B at the head of vector A such that its direction does not change. And so this is vector B. If I move it at the head of vector A, considering vector A is my first vector, in that case you move this vector B in this direction at this point such that its direction does not change. You see it's going in this direction, at this point too it's going in this direction. So you do not change the direction, you do not change the length of the vector, you just move it such that it ends up at the tip of first vector. And now at this point you can immediately find your resultant vector. So you start from this point, the tail of first vector, and you draw a line to the head of last vector. In this case it's your resultant vector, which let's call it vector S. So vector S equals vector A plus vector B. Okay. So I said that it depends on which vector you consider as your first vector. In all these cases that I have talked about, I have considered vector A as my first vector, vector f as my first vector and this blue vector A as my first vector. But there is no restriction on that, like which vector you take as your first vector. You remember from the simple numbers that when you add numbers you are like 4 plus 5 equals 9, you know that. What if you reverse the order of addition? This says that you add 5 to 4. What if I write it like 5 plus 4? This is still gonna be 9, right? What's the difference between these two lines? That in the first one I'm adding 5 to 4, in the second one I'm adding 4 to 5, but the result is the same. It doesn't make any difference. I'm going to prove the same thing for vectors 2 here. So I have added vector B to vector A. What happens if I add vector A to vector B? Like what if I want this thing, vector B plus vector A. So in this case I will keep B in its place and I will move vector A at the head of vector B. And if I do that, this vector A should end up like this. Same length, same direction. And you see in this case the resultant again is this vector S. So I have proved to you that in case of vectors, vector A plus vector B, this was equal to vector S. But if you change the order of addition, like if you add vector A to vector B, you get the same result. So they kind of follow the same property. This is the only property that vectors shares with numbers, that the order doesn't matter. Which vector you consider as your first vector, which you consider as your second vector, it does not matter. It gives you the same result, and this is the geometrical proof of that. That they all give, both kind of addition gives you the same, this magenta, whatever color it is, this vector. So this first question is related to this one. That's all you need to do. You can choose your first vector, you choose your second vector, you place second vector at the head of first vector, and then you coincide the tail of first vector to the head of last vector, and this gives you your resultant vector. Subtraction, this was vector addition. Vector subtraction is a little different. Let me go with subtraction now. So in order to subtract two vectors, you again need to recall something from your basic training of mathematics. When you had numbers, let's say 9 minus 5, this gives you 4. Everyone knows this, right? But have you ever seen this, that this subtraction, it's actually addition? Like you can write it like this, 9 minus 9 plus minus 5. This gives you the 4. What's the difference between these two lines? The first line tells you it's a subtraction. The second line tells you it's addition. But it's addition of a positive and a negative number. In this case, it's explicit that 9 is a positive number, minus 5 is negative number. But when you add both of them, they just give you this thing. They just become subtraction, right? Now if you take 9 as your vector, let's say this is some vector A, and you add to this as your vector B, this gives you some resultant R. Now you do the same things, play the same trick here, but you do, okay, this one was subtraction, and now you do the same thing but with this trick. Should this give you vector R? So this thing is true in case of numbers. The question is it true in case of vectors? What do you think? I told you that basically they are different quantities. If they share some property, that can be an accident, but they are not they are not under some bound to follow the same properties like as numbers have. So what do you think? What's the guess? Should this resultant R be same as this one, as it was in the case of numbers? We can actually figure it out. Let's try to do it. So again, let's try to draw two vectors. Let's say we have this one as our first vector. Let's call this vector A, and this one as the second vector as our vector b. Okay, so they are both positive vectors. So they are currently positive, and what if I want to get this expression out of them? Here it's explicit that A is a positive vector but B is a negative vector. So I need to make, first need to make B as a negative vector. How do I make a negative vector from positive vector? I just change the direction. Okay, so if I change the direction of this vector, it means that I have to take this arrowhead from this side of the line and bring it to the other side. And so in this case, my negative B should look like this one. It's the same length as this one, but now the arrowhead is on the other side. So the vector is pointing in the other direction, right? It's the example when I say that if I walk towards bell tower, that's a positive vector. But if I walk in the opposite direction of bell tower, that's the representation of that. So I can walk the same distance in the opposite direction, but now my direction is different. So I'm going away from the bell tower. That's what it means to be a negative vector, to change the direction of a vector. The rest is same. Rest is just addition. Okay, it's just the head to tail rule as we were doing. So I need to take this vector b and put it here on the tip of first vector. So I do not change the magnitude. I do not change the direction. This is my negative b. This was positive b. And now if I draw a line from start till the end of last vector, this is gonna be my resultant vector. And in this case, Q is vector A, and since I have used head to tail rule of vector addition, so I'm gonna put a plus symbol and I'm gonna add the second vector, which in this case is negative b, and so this gives me A minus b. Okay, and you can see that the length, this length is simply not equal to the length A plus b, like if I had added this vector here. Okay, so in that case this would have been the resultant, and you can see that this is way more length than this one. And so the result of these two expressions, it's not equal. So they do not follow the property as numbers does. So the vectors again are different things from simple numbers. That's the second part of the question. So whenever you subtract a vector from the other vector, you change the direction of one vector which you are subtracting from the other vector. So in this case I had b positive, so in order to make minus b, I just changed its direction. I just changed its direction and then added it to the first vector, and I got the resultant as a minus b. That's the subtraction of vectors. Okay, now let's get to some serious stuff, and that is how do we actually find the resultants in numbers? Like if I have given the values like 5 and 4 of values of a and b, how I'm gonna find the numerical value? This is this part related to, and so the first question is, we have a vector a. By the way, this thing is called resolution of a vector into its components. So I'm gonna plot the x-axis and the y-axis as I did before, and I am given with a vector a, and the vector a is in this direction. So this is my vector a, and its length is given, it's 5, and its angle is given, this one, and it's 130 degrees. Okay, so this is called resolution of vectors, because what we do in this, we resolve this vector a into its components. What we mean by components, that if I was standing at this point initially and I wanted to go at this point, how I am going to go to this point? The condition is that I am only allowed to walk on this line or on this line. How I'm going to get to this point then? It simply says that if I am only allowed to walk along x-axis, this line, or this line. The only way that I can get to this point from this point is that I first walk along this line which is along negative x-axis, and then I walk along this line which is along positive y-axis, and eventually I will end up at this point. So what I have done here, I have resolved this vector into its components, like the total length of the vector. I have resolved that sum of that length to along x-axis and sum along y-axis. So this length which is along x-axis, it's called ax component, and similarly the length which is along y-axis, it's called the y component of a given vector. And how do we find them? We find them by using these formulas. So for x-axis, it's vector a times cosine of angle theta, and for y-axis it's vector a times sine of angle theta. Okay, so this a is the length or magnitude of vector a, and we are given the length as 5 units. Units can be anything, it can be meters, it can be feet, inches, anything. So they are 5 units, and the angle that it makes with the positive x-axis is 130 degrees. This is very important. Angle that you measure, you always measure corresponds to positive x-axis. Be very careful about this point. Sometimes you will not be given angle with the positive x-axis. You will have to convert it with respect to positive x-axis. So in this expression you can use the value 5 for vector a, and then you can use cos of 130 degrees. Similarly, you can use the value 5 for a, and now you can use sine of 130 degrees. Can someone calculate these values for me, please? Do you have calculators? I want numeric value for this and this. Are you calculating? We are waiting on you. No? Yeah. Okay, great. 3.83, this is for the top one?
No, the bottom one.
This is for the bottom one. What's the top one? I'm going to write units with it because it eventually shows some physical quantity, and they come with the units.
Negative 3.21.
It should be negative. Negative 3.213. That's enough. Okay, question. The length of our original vector was 5 units. Here we have minus 3 and plus 3. Even if we add them, they can either make, like, we can add them or subtract them. If we subtract them, they're going to give us something around 7. And if we add them, they're going to give me something around 0.6. They do not seem like being equal to 5. What's going on? I mean, it's like you have a meter stick and you divide it into 3 parts. What do you expect that if you try to add those 3 parts separately, when they were separated, you want to add them, they should end up in 1 meter, because the original length was 1 meter. It is not possible that you divide a meter stick into 2 parts and then the length of those 2 parts add up to more than the length of the meter stick or less than the length of the meter stick. It doesn't make sense. In this case, if we subtract them, they're going to give me something like 7.06, we can see. And if I add them, they're going to give me the difference, and that it will be 0.6. They do not seem to make 5. What's going on here? They are vector quantities, as I have been saying since the start of this lecture. They are vector quantities, and you cannot just simply add them or subtract them like numbers. So what I'm trying to say here, like if we subtract them, they give me 7. They will give me 7 if they were numbers, but they are not simply numbers, they are vectors. Okay, and so in order to get the vector back, like this length back from these things which are called components, I have to use a different formula. They follow a different formula, and that formula is you can calculate the length of vector from its components by using this formula. And now you can cross check it. You can plug these values back in this formula and you will see that it indeed turns out to be equal to 5 units. Okay. So the vectors are like different from numbers. They do not follow the same rules which numbers does. And this part is again, I believe, some question. So this first question, it has 3 parts. You are just going to use these 2 formulas to calculate the components. And when you have the components, you can calculate the magnitude of vectors, and that's your next question by using this formula. I'm going to solve that one part. Okay, where is this? Let's take, for example, this is exercise 18 to 20. I'm going to take exercise 18, just randomly picked. Again, coordinate system, x-axis, y-axis, and now we are given that ax, it's equal to 3, and ay, it's equal to minus 2. Okay. Now you know that this is positive x-axis, this direction is positive y-axis, this is negative y, and this is negative x. And you can divide these axes into some length scales. This is 1, 2, 3, 4. Similarly, 1, 2, 3. That's enough for us. Okay. So if you want to draw these lines, the x and y components of vector A. How do we draw x component? It's the length that vector travels along x-axis, and we are given the length ax equals 3. It means that this line, it starts at this point and ends at 3. So this is ax. Ay is negative 2. Now it's 2 and it's in the negative direction, and negative y-axis is downward. This is positive y-axis, which means I need grading here. So this is 1, let's call minus 1, minus 2, minus 3. So the minus 2 is this line. So my ay equals minus 2 will be, it starts from this point, comes down and ends here. So this is ay. And now you can see, if you want to find the vector A, you simply use that head to tail rule. This is your first vector, second vector, and head to tail rules tells you that this will be the length of your vector A. Okay. So that's how you draw it, and the question asks, what is the magnitude of vector A? So you need this length, and this is the formula for this length. Okay. So A will be ax, which is 2 squared, plus ay. Ax is 3 and ay is negative 2 squared whole square root. 3 square is 9, minus 2 square is 4, and so this becomes square root of 13. So this is the magnitude of your vector A. The rest of the 2 parts in this question, they are similar. And I ran out of time, and the question 32 to 34, they are also similar. So this is the basic concept behind vectors and how you find components out of this.